thank you all for coming. Appreciate it. My name's Vince. I'm one of the co-founders and the CEO of Plastic Labs. If you've never heard of Plastic Labs before, we're working on a dev tool called Honcho, which is a library for building agents with memory. But it goes much further beyond memory, which I hope to explain a bit more today. So I'm going to talk about how we think about memory as a reasoning task. So I'm sure if you guys are on Twitter at all, agent memory is all the rage. I feel like every other day I see a startup thinker or investor talking about, like, we just got to solve memory, and that's going to be like our key to the AI revolution. And I don't necessarily disagree. I just think you have to come at it from an AI native perspective, and so for it to really work. But what you see in the space today is people treating memory as storage. So first up, you've got your good old relational databases. I think these things are timeless. They solve almost all of your problems. I think a relational database is good for almost like any use case you have. I think most people who try out different agent frameworks find that configuring them to do more complex things as your product progresses ultimately ends up being harder than just scrapping it, rolling your own solution, and using a database. And basically all of them have added support for vector embeddings, which is just, they offer a language model-based form of storage where your text sequence gets run through a special LLM to turn it into an embedding, and that's just a vector representation of the sequence. And that's cool because you can do math on vectors. And you can compute distances between these vectors, which essentially represents semantic similarity. So no longer are you bound by just raw string matching and Elasticsearch. You can match on ideas. So the sentences, the cat sat on the mat and a feline rested upon the rug, contain none of the same words, but mean basically the exact same thing. So people have done really cool things combining Elasticsearch with semantic similarity. And then there's graphs. People have combined a lot of these things into graphs. Yeah, that emoji is representative of how I feel about graphs. If you know me, you know I kind of hate graphs. I just think they're made for humans, not language models. It's clear that they scratch an itch in our brains that makes us really happy. And don't get me wrong, like, I'm a PKM nerd. I've got my Obsidian workflow dialed. Our company blog is a hosted Obsidian graph. It's a Quartz website. I love it. Everybody can contribute to that. That's open source. We've yet to get our first PR on our blog. But just from an LLM memory standpoint, I don't like them. I find them skeuomorphic. They mimic how humans use associative memory because we can't do exhaustive reasoning. So we've created these like cognitive shortcuts. But cognitive science tells us that memory is prediction. It's not storage. One of the leading theories around how the brain works is predictive coding, which basically says that we're constantly running prediction and checking against data that comes in through our senses. We rectify prediction errors and continue to make predictions in light of new data. Developmental psychologists describe this through a framework called violation of expectation, if anyone's ever heard of that. Basically, the theory is that, like, when we're young, we don't have very good or solid models of the world, right? So everything is surprising. Babies are constantly surprised, very easy to surprise them. But as we get older, our world model becomes much more solid and really just checking for surprise at the edges where our expectations get violated. And so that's inspired a lot of our building for quite some time. But importantly, prediction requires reasoning. When we recall memories, what we're really doing is reconstruction. We remember something faint, then we reason further to reconstruct the full picture. Then after that, we're double checking ourselves, right? Like, oh, is that how it happened? Like, am I remembering that correctly? We're seeking to assign credibility to the memory that we just constructed. And then once we feel confident that it is true, we seek to attach meaning to that memory. Like, yes, that happened, and it was because of X, Y, and Z, and that means this going forward, right? So all of that is pretty intense reasoning, kind of like a brain blast, which is easy for Jimmy Neutron, but hard for the rest of us. When we really need to think about something, we burn a lot of calories, it causes us stress. We literally get tired from thinking too hard. When you come home from a really mentally demanding day, you're exhausted. That's your brain hitting its limits. We can only do high quality reasoning in really short sprints. And even though we're constantly second guessing ourselves or forgetting key details, or falling into like mental shortcuts that lead us astray, we're also terrible at updating our priors. If anybody's like a Bayesian in here, when new information comes in and our expectations get violated, it's really hard for us to update our models of the world. Think about forming habits, right? There are plenty of things we know would be good for us, but for whatever reason, we just have a really hard time adopting them. And as time goes on, our neuroplasticity decreases. And this is just one of a number of adaptations we've evolved to work with in order to use our extremely limited compute capacity up here as efficiently and as effectively as possible. So it's been useful up until this point, but we've learned these cognitive shortcuts because we literally cannot reason through everything from first principles every time. But LLMs can. And there's been a huge explosion of research and products in this direction recently. So first it started by asking the model to think step by step. I remember like really early on seeing this emerge a lot, and everybody was talking about chain of thought, chain of thought, chain of thought. And it took me way too long to realize it was literally just appending think step by step to like the end of your prompt. But they found that prompting for explicit reasoning dramatically improved performance on a various number of benchmarks. Then people started doing reinforcement learning on desired outputs, initially using human feedback with RLHF, and then in Anthropic's case, AI feedback based on like a constitution that they gave Claude. And this showed that LLMs could learn to reason about their own behavior, but optimizing only on those final outputs led to brittle models that could sound reasonable without actually reasoning well. So researchers combined the two insights. They started applying reinforcement learning directly to the reasoning process itself, computing rewards based on whether or not the reasoning led to correct answers, which created a breakthrough realization, right? As we're hitting the limits of pre-training scaling, there are no limits, or we're nowhere near the limits of scaling post-training and inference time compute. So OpenAI's O1 demonstrated this with hidden reasoning traces showing dramatic improvements on math and coding benchmarks, which implied that they needed a verifiable reward. And then DeepSeek came in and blew everything up by reverse engineering the method and open sourcing the model. And it's all sort of related to this idea, like what if we give the language model more time to think, more of a token budget to really sort of like hash it out? Does that increase the likelihood it arrives at the correct answer? The answer is yes. So DeepSeek, yeah, like I said, they came in and like really blew this all up with R1 and the GRPO method. They continue to really push forward here with self-principal critique fine-tuning, which is sort of similar to the constitutional AI approach, where at inference time they have the language model generate like a large number of like ways to principles to follow and then ways to critique its outputs, and they only accept like the most effective ones that lead to the right answer. So, and Scale AI released a research paper recently that was doing something similar with like a rubric as a reward. Yeah, so like people are trying to move beyond just math and coding and have general reward models that can do many other tasks. So since memory is actually prediction, and prediction requires reasoning, and we have these LLMs that are excellent at reasoning and prediction, how would you leverage them for memory? Again, we want to think in an AI native way. LLMs don't have the same compute constraints as us. They can be trained to do the hardest types of reasoning for humans and generate inferences effortlessly. And agents should have perfect memory, which means perfect prediction, perfect reasoning, and it should adhere to the bidder lesson, meaning it should scale. So this is how we arrived on logical reasoning as the task to train for memory. Logical reasoning is the process by which we derive conclusions based on premises that serve as evidence to support that conclusion. I'm sure you've all heard these terms before. There's deductive conclusions, inductive conclusions, and abductive conclusions, and each of these live on a spectrum of certainty. Deductions are certain conclusions supported by premises that were explicitly stated or observed. Inductions are conclusions that observe patterns, and then abductions are basically hypotheses that seek to explain everything in the simplest way possible. And it might not come as a shocker, but LLMs are fantastic at this task. Importantly, this allows us to scaffold an understanding of the user that can be computed over dynamically. So that's the issue with graphs. They derive static associations based on the context they're in. They can't be composed because the association is the product. When new data comes in, you need to recompute the entire graph. But the logical reasoning approach derives evidence that builds a case, an argument. And that case can be different each time you compose it with the evidence that exists. The model has a natural language framework that's very well represented in its pre-training for computing those associations dynamically, based on the context they're in. And since it goes from the explicit deductive level all the way through the inductive and abductive level, then what you're able to provide is a much richer picture of the user than just memories. So I mentioned at the beginning, but we believe this goes beyond memory and approaches true social cognition. If you can use these logical building blocks to cover this full spectrum of probability as it pertains to an individual user in any arbitrary context, then not only is memory effectively solved, but you can begin to trust that your agent has awareness, understanding, and real continuity as it pertains to your task. So that's what we've been up to recently at Plastic Labs. We've been distilling small reasoning models that are essentially little logicians that I'm excited to share are now running on the back end of our hosted service. And because logical reasoning is so well represented in the pre-training, we're essentially eliciting and channeling this learned behavior, which is why we're calling them the Neuromancer series of models. If you're unfamiliar, it's named after a sci-fi book where there's a character who is very concerned with personality, memory, identity, and the preservation of consciousness. So it literally romances neurons. It's drawn to human minds and experiences. So we currently have two variants of the Neuromancer models, Neuromancer XR, which stands for explicit reasoning, and Neuromancer MR, which stands for meta reasoning. The XR models seek to do explicit reasoning. They're concerned with what can be derived certainly from new information. And the meta reasoning models are literally reasoning about reasoning. So when the certain items are derived by the explicit model, the meta reasoning model uses that as source material to do more predictive reasoning. So this is an early concept of the model art. It's not final, but it looks cool. And we're seeing some really promising results on some pretty popular memory benchmarks internally, even with the whole framework being essentially incomplete. Logical reasoning approach is quite robust to numerous types of questions that can be asked about a conversation. So we're finding the limits of the evals themselves, which is really interesting. Happy to talk more about that as time goes on. So all right, I've talked about memory and reasoning broadly, how Honcho's doing reasoning. But I said at the beginning it's a dev tool, right? It's something you can build with today. You can think of it as a super lightweight memory framework for building agents. You can instantiate a client, which creates a workspace, and then you can create what we call peers, which are essentially any actor in your workspace, human or AI. We don't discriminate. And you can write logic to open sessions for any arbitrary number of peers and write messages to them. It's those messages that serve as the source material over which we do logical reasoning, completely ambiently, in the background, with no involvement from the user or the developer at all. So you don't need to upload or connect your docs, your emails, your Notion, messages, anything to bootstrap these representations. We're leveraging LLM's native abilities to mimic human social cognition. We don't really get to know each other by reading our knowledge work artifacts, right? We get to know each other by hanging out, talking in person. So it's a very social process. But from a developer perspective, we're not trying to replace a database. We want to slot in as minimally as possible in order to give you the benefits of our reasoning services. And you can access the insights we've reasoned about via a simple chat method, which takes in a query in natural language. And we have also a very configurable like get context method that allows you to just do summarization and chat history curation. So we talked about why reasoning matters from a memory perspective, but why does it matter from a product perspective? We want to help entrepreneurs play data games at the scale of large incumbents. And what that means is helping people engage in positive data flywheels. If you're like us, you've felt the pain of hitting the limits of memory, where your agent is fundamentally limited in the service it can provide because it lacks available context. When you hit this limit, the natural next step is to figure out ways to drill down into someone's life and collect more context, which you're seeing with a lot of apps right now. Eventually, you'd be modeling the entire identity of the user and rebuilding Honcho. So in order to make things easier on builders, we're taking care of the general identity modeling aspect of things and looking to enable builders to focus on becoming expert in their use case, domain, and vertical. If you have highly bespoke outputs paired with rich personal context, then you can begin to build a data set that foundation model providers don't have access to. And if enough people do that, then we can cover a broader set of use cases and go deeper on them than any single incumbent could in order to create a competitive ecosystem of applications. Plasticlabs.ai, our landing page, says radically decentralizing alignment because we believe rich memory, social cognition, and ultimately identity infrastructure is the key for unlocking a future where our virtual identities aren't owned by some closed corporation. So that's part of the vision for Honcho, is to become like a trusted, open source, user-owned layer, identity layer for the AI world. And I'm almost done, I got one more slide. This is it. All right, so I'll leave you with a few questions. If you could trust that your agents could reliably integrate with all the tools you need via Smithery or MCP or whatever, and memory within your task was solved, you could just trust that it would remember things, and each agent was stateful enough to simulate true social cognition, do you think you would be spending most of your time on context engineering? I think the answer is no. Then you'd find the most important thing to spend time on is the identity of the agent itself. Is it someone people like? Is it someone people enjoy working with, enjoy using, enjoy interacting with? We talk a lot about this at Plastic. Time and time again, we see that the identity is the product. People went to Microsoft's Bing chatbot to elicit Sydney. Truth Terminal kicked off a multi-billion-dollar meme coin wave with hundreds of copycats. And Anthropic is quite transparent about their desire to engineer the identity of Claude, and then there's Grok. I don't think I need to say much about Grok. So this is the direction the space is going, and we want to help people build the most impactful retentive agent possible. That's it. If you want to get email updates, that's our type form behind the QR code. We're looking for early users. Come talk to me or Major. If you want to work with us, we have the MCP server, which is live. You can use that to give Claude memory, or you can use it for your own apps. App.honcho.dev is also, you can self-serve, sign up, get an API key, start building. And we do dev streams every week. It's building something with Honcho, Thursdays, 3 p.m. Thank you, guys.